Hi, Assalamualaikum. Today I will present home network design and improvement. Introduction. For my client overview, they are subscribed to Unify, a leading ISP in Malaysia, and the current setup consists of a home gateway unit, a Skyworth AX3000 GPON HGOS, serving as a modem, router, and Wi-Fi AP. This home setup to support multiple devices such as smartphone, laptop, smart TV, and PCs. And then I have identified the challenges, which is a slow internet speed in certain areas, especially during peak usage, and insufficient Wi-Fi coverage across both floors. Problem statement: a weak Wi-Fi signal in certain rooms, bandwidth congestion, device capacity limitation, unoptimized device placement, and potentially overlap of interference. So for the objective, I want to ensure a full Wi-Fi coverage, optimize speed and performance, increase device capacity, and strategic device placement. Okay, so for the current home network, they consist of a HGO, which functions as modem, router, and Wi-Fi AP. And the hierarchy of the network components only consists of core layer and access layer. The core layer is between the ISP and the HGO, and the access layer between the HGO with the mobile devices and PCs. And then on the right is the physical diagram of the network, and the left is the logical diagram. Okay, so for the cabling details in the network, from the ISP to the HGO unit, we are using a fiber optic cable, single mode fiber, using a connector of SC SPC connector. This is because the fiber optic cable is used to connect the ISP to the HGO. And for the HGO, there are Ethernet port, and then thus we can use the Ethernet cable, Cat5 in this case, using the RJ45 connector to be connected to the client PCs. Okay, so for the network device they are using Skyworth AX3000 GPON HGO with a system on chip with dual core CPU. It is also a with Wi-Fi Easy Mesh with the maximum PON speed of 2.5 Gbps and 1.25 Gbps. The Wi-Fi standard is the IEEE 801.11b/G/N/AC and AX. And the maximum Wi-Fi speed for the 2.4 GHz is almost to 574 Mbps, and 5G is almost to 2402 Mbps. The optical interface consists of one SCPC, and the LAN interface also have a 4 gigabit Ethernet ports RJ45, and the Wi-Fi antenna is 2 for 2.4G and 2 for also for the 5G. All is omnidirectional. Okay, so right now is the current Wi-Fi heat map. I've done it using a Netspark software app, and then it showed the HGO in the top right room, and it is accurate. They are detecting two network, Asamboy 2.4 GHz and Asamboy 5 GHz. The yellow color indicating a great strong connection speed, meanwhile the green area showing a weaker connection. Thus we can see the yellow is only at the top right corner, meanwhile the rest of it consists of green area, weaker connection. Okay, for the network speed, the 2.4 GHz have a moderate performance with higher latency and jitter, but yet no packet loss. And for the 5G consists of a strong performance, low latency, minimal jitter, and stable connectivity with no packet loss. So for the network traffic, we can see the throughput and latency is actually okay, but this is during the unpeak hour, and then we are also preparing for many devices. So this is a very neat improvement. So for the proper solution, I am going with a 1 Netgear Nighthawk CM1200 for the modem, and 4 Netgear Orbi RBKE 963 for the mesh Wi-Fi system. From the performance enhancement view, the modem consists of latest technology supporting speeds up to 2 Gbps. They are also for link aggregation for high speed, ideal for gaming, streaming, and file transfers. The benefits is the faster and reliable connection with minimal latency and interruption. Meanwhile, for the Netgear Orbi Wi-Fi system, they are supporting a Wi-Fi 6E with tri-band 2.4, 5 and 6 for up to 10.8 Gbps of speeds. The benefits of it is the faster speeds, seamless coverage, reduced latency, and better capacity for multiple devices. From a security measure point of view, the Nighthawk consists of a comprehensive protection for all devices connected to the network, and the Orbi have a protection against malware, ransomware, phishing, enhanced encryption, and secure remote access. And lastly, scalability. For the Nighthawk, there are seamless scalability for the future network growth, and the Orbi have a scalable network for more devices, larger homes, and growing smart home ecosystem, including IoT. So this is a proposed diagram for the network. On the top right is the physical diagram for the location, and is one on the top left, one on the top right, one at the middle, and one at the bottom right, and then the logical network. And then I've done also the heat map prediction, which cover almost a red and yellow area, which is very good for the network. Okay, for the proposed cost, the final total estimated cost is 15,000 ringgit. That's all. Thank you.